Hi everybody, today we're going to start talking about trigonometric functions. We will look at this from a right triangle approach. We will cover sine theta, cosine theta, and tangent theta. As a quick reminder, right triangles are triangles with one 90-degree angle. Basic trig functions are ratios of sides based on a reference angle of a right triangle. Let's talk about the components of our triangle. You can see our right triangle, and theta is our reference angle. Across from theta, we have a side that we call the opposite. Beside theta, we have a side that we call the adjacent. The longest side, which is across from the 90-degree angle, is called the hypotenuse. Sine theta is the ratio of the opposite to the hypotenuse. Cosine theta is the ratio of the adjacent to the hypotenuse. Tangent theta is the ratio of the opposite to the adjacent. It's important to note that tangent theta could also be expressed as sine theta divided by cosine theta. Let's use our definitions to find the indicated values. We'll start with sine theta. Our opposite is 12. Our hypotenuse is 13, so sine theta is 12 divided by 13. Cosine theta is a ratio of the adjacent 5 to the hypotenuse of 13. Tangent theta is the ratio of the opposite 12 over the adjacent 5. Our second triangle has a reference angle of alpha. Sine of alpha will be the opposite 9 over the hypotenuse 15. Cosine of alpha will be the adjacent 12 over the hypotenuse of 15. Tangent of alpha will be the opposite 9 over the adjacent 12. This time we can reduce all of our fractions. 9 over 15 can reduce to 3 over 5. 12 over 15 can reduce to 4 over 5. 9 over 12 can reduce to 3 over 4. You should always simplify fractions if possible. Our next angle gives the reference angle of 45 degrees and it gives an opposite side of 7. Notice that we are missing both the adjacent and the hypotenuse. Since we know that we have a reference angle of 45 degrees and a right triangle, we can find the remaining angle. 45 and 90 adds up to 135, so to find the missing angle, we would take 180, the number of degrees in a triangle, and subtract 135, which gives us 45. To find the adjacent, we use the fact that we have an isosceles triangle, which says that both the opposite and the adjacent will be equal, so our adjacent is equal to 7. Lastly, we need to find the hypotenuse. To find the hypotenuse, we need to use the Pythagorean theorem. The Pythagorean theorem says that a squared plus b squared equals c squared, where c is the hypotenuse. In our case, we have 7, 7, and a missing side. 7 squared plus 7 squared will be equal to c squared. That says 49 plus 49 is c squared. I'm going to write this in an unusual way. Instead of saying 49 and 49 is 98, I'm going to say 49 and 49 is 2 times 49. This helps me when I go to find the square root. I take the square root of 2 times 49, I take the square root of c squared. The square root of 2 is an irrational number, so I can't simplify it. But the square root of 49 is 7, so I'm going to write this as 7 squared root of 2, and that's going to be equal to c, my hypotenuse. Now that we have all three sides of our triangle, we can find our trig functions. The sine of 45 is going to be equal to 7 over 7 square root of 2. The cosine of 45 will also be 7 over 7 square root of 2. And then the tangent will be 7 over 7. Remember, we said we want to simplify if possible. Notice that all three of our ratios have a 7 in the numerator, a 7 in the denominator that can be canceled. For sine, I have 1 over the square root of 2. We don't like to leave radicals in the denominator, so I multiply by the square root of 2 over the square root of 2, which gives me the square root of 2 over 2. Cosine will be exactly the same. 1 over the square root of 2, when I multiply by the square root of 2 over the square root of 2, simplifies to the square root of 2 over 2. Tangent 7 over 7 is equal to 1. Our next triangle asks us to find the missing side of the triangle. So we're given an angle of pi over 6, and I know the opposite is equal to 5. Because I have the opposite, I think to use sine. Sine is a ratio of sides. It will have the same value for any size of a triangle for a given angle. Put sine of pi over 6 in your calculator. I want you to notice that we don't have to tell the calculator the side of the triangle we're using. We just need to give the reference angle. When using your calculator to evaluate trig functions, make sure your mode is the same as the format of your angle. You will need to be able to switch between degrees and radians on your calculator. This will help make calculations faster and avoid having to do conversions on your own. Make it a habit of checking your mode. So I'm going to show you in Desmos that when I first come in, it says I'm in radians. So I can put the sign of pi over 6, and it tells me that the value is 0.5. Check your calculator, put in the sign of pi over 6, and see if you get 0.5. If you don't get 0.5, you need to change your mode. Notice that in degrees, it gives me a value of 0.009. So make sure you switch back and forth between degrees and radians as needed. Now that we know the sine of pi over 6 is equal to a half, that tells us that 5 over h is equal to a half. If we cross multiply, 5 times 2 is 10, is going to be h, the value of our hypotenuse. Let's try using the Pythagorean theorem again. This says I have 5 squared plus b squared is 10 squared. 5 squared is 25. I have plus b squared, 10 squared is 100. Move the 25 to the right. B squared is 100 minus 25, which is 75. I take the square root of b squared, I take the square root of 75. B then is equal to the square root of 75. It might help to look at 75 as 3 times 25. Square root of 3 is irrational, so I leave it alone, but the square root of 25 is 5, I bring that to the front. This says our last side is 5 square root of 3. A guy wire is attached to a radio tower at a point 49 feet above the ground. If the wire attaches to the ground at an angle of 54 degrees, find the horizontal distance from the base of the tower to the end of the guy wire. Let's start by drawing a picture. I know my height is 49, and I know my angle is 54 degrees. We want to know the value of the adjacent, let's call it x. Thinking through our trig functions of sine, cosine, and tangent, tangent will be the most helpful because it incorporates the opposite and the adjacent. The tangent of 54 degrees is going to be equal to the opposite 49 over x. To find the value of x, I'm going to multiply both sides by x to get the x out of the denominator. Now I have x tangent of 54 is 49. To get x by itself, I'll divide both sides by the tangent of 54. So x is going to be 49 over the tangent of 54 degrees. Let's go back to the calculator and put in 49 divided by the tangent of 54. This time our angle is in degrees, so I go over to my settings and I switch to degrees. This tells me the x will be 35.6. Our original distance was feet, so x will also be in feet. How long is the wire? Instead of using the Pythagorean theorem this time, I'm going to use trig functions. I note that the sine of 54 will be 49 over the value of our hypotenuse h. So to find h, I can multiply both sides by h and then divide by the sine of 54. Let's go back to the calculator to find our value. We have 49 divided by the sine of 54. It says 60.567. Let's write that as 60.57. Our last question says an asymmetrical hill has two paths. It has a 15-degree elevation path on the west entrance and a 25-degree elevation path on the east side. If both paths meet at an elevation of 900 feet, find the horizontal distance between the starting points. We want to find the overall distance from the left to the right. Let's call the first one A, we'll call the second one B, and let's write in that we know our height is 900. In both cases, we're looking at the relationship between the angle and the opposite and the adjacent, which says we're going to incorporate tangent. So if I take the tangent of 15 degrees, it will be equal to 900 over A. If I take the tangent of 25 degrees, it's going to be equal to 900 over B. We're trying to find the value of A plus B. In the first equation, let's multiply everything by a. I have a times the tangent of 15 degrees is equal to 900, which says a will be 900 over the tangent of 15 degrees. We can do similar steps to find the value of b. If I multiply everything by b, I have b times the tangent of 25 degrees is equal to 900. So b is equal to 900 over the tangent of 25. We want to find the value of a plus b, so we want the value of 900 over tangent of 15 plus 900 over the tangent of 25. Back in the calculator one more time, we have 900 divided by the tangent of 15 plus 900 divided by the tangent of 25. Altogether, it says that's a distance of 5,288.9 feet. So let's write in our value of 5,288.9 feet, which says that these two endpoints are about a mile apart. In future videos, we'll talk about special triangles, 30, 60, 90, 45, 45, 90, and we'll introduce 3 more trig functions, secant, cosecant, and cotangent.